But with that, I'm going to turn it over to David Backx. He'll be showcasing how he's using OpenMetadata. Thanks, David.
Yes, thank you, Nick. I'll be sharing my screen quickly. Okay, so if all correct, you can see my screen now.
Yes.
Okay, so I'm David. Um, I'm David, data engineer, currently working for a consultancy company, Dataroot, located in Belgium. Currently working for a project for the VRT, which is the public broadcaster in Belgium, where I'm part of the data and intelligence department. We're maintaining and expanding a modern data platform with a focus on data governance and data quality. We also closely work together with some data teams and a lot of business domain teams as well. So to get started with the talk, does this sound familiar to anyone? I'm guessing yes, because we all kindly work together with data. We have some kind of reported breaks, customer-facing application is impacted. A lot of teams, they get together, trying to locate the issue. And after a few hours, we can come to the conclusion that a business user has inputted inconsistent metadata, no metadata, the wrong metadata. It's understandable given the growing complexity of all the systems, but it costs a lot of time, money as well for all the people working on it. And in the end, it has customer impact, which we should avoid at any cost. So there's really a lot of importance on keeping this metadata correct and consistent. So how does this kind of take shape in broadcasting? We have a lot of different teams who have all kinds of different data. Think about series, shows, movies, articles, but also podcasts. So we're already working with a lot of different data. This all gets put into a content management system, where then the business users also put in the metadata of the data. And this kind of flows through a lot of different touch points. For example, we have a streaming service, but also a page where all the articles of the news are shown, and many, many more touch points. So why is fixing this a challenge? Business units often they lack the technical skills or even access to perform these analysis on data quality test cases. So it's really our job to provide them with all of the specific information of the test case. Also, the business users, they own the knowledge, but not really the tools. For example, making some customization of a content management system is difficult, and it's also something you really don't want to do. And also, the goal is also to really inspire ownership towards the business owners, to make them the owner of the data. So in the end, that they can implement the fix as well. So this is also really important. So with the help of OpenMetadata, the data quality tests, we were able to identify the elements where the metadata wasn't consistent or could cause issues. For example, I did an example of if you have some kind of Christmas special, you don't want it to show up where all the normal episodes are shown, for example. This could be the result of metadata being incorrect and also then having impact on the customer. So the first solution which we tried out was an open metadata alert that a data engineer would receive. The data engineer would then go and query the data and do some analysis on it, send it to the SPOC team or the business team, who then could implement a fix. Now, this didn't really got the results we wanted. The data engineer quickly becomes the bottleneck because of the growing test cases. Also, context switching is difficult. Takes up a lot of your time. and they don't have time to focus on their own tasks. Also, there's no really ownership towards the Spock team. It's more of an annoyance towards them that we always send them like, hey, this kind of failed. Can you look at it? So there's no ownership, more of an annoyance for them. So another solution that we tried out was an open metadata alert again. But then now we added a URL to the alert, which then gets sent to the Spock team and not to the data engineers anymore. They could then look at the report and find out where the missing or the inconsistent metadata is. This was also not the desired solution because it was yet another report we had to keep in sync with all of the growing test cases that we have. Also, it didn't really inspire urgency towards the business owners. And again, we still have multiple steps before we can come to a fix. And also the quality of life isn't that good because it's another report you have to manage. So we got to thinking, what would the ideal solution look like? And also why do we want to tackle this? I mentioned in the beginning already the possible impact of inconsistent metadata. So it's important because it could have customer or consumer impact and also on heavily used reports. Also, we want the ownership on the business owner on the business side and not and don't have engineers as a middleman. Also, how could we achieve adoption? You need one point of truth, like one source of truth. In our case, it's open metadata, else I wouldn't be here. It should also be easily configurable and scalable because of all of the growing test cases that we have. Ideally, it would also be customizable per use case. And very important, it should also stay within the client ecosystem. We don't want any third party interacting with the data. It should all stay within our ecosystem. And also the quality of life should be very high because we don't want it to be neglected after some time. So what would this solution look like? We came up in the end with an email, a multifunctional email triggered by a webhook. So it looks like the following. Still have an open metadata data quality alert. That when gets triggered, it creates an email with all the needed information for the business users to act upon this and implement a fix. So I'll quickly go over the architecture of what we set up. Sorry. So we start with a failed data quality test. This you could specify an external destination. In our case, it's a webhook, and in the background, it's a Lambda function, but this could be any kind of cloud function. First step is to parse the given event and also fetch the test type. We have multiple tests. If you ever used metadata, you have built-in tests where you can specify custom SQL tests, but also they have some pre-built tests for you. And we also have DBT tests. That's an external tool, which you can also put in OpenMetadata. So the next step for DBT test, we save the artifacts, so we can just fetch the SQL back from there. From custom SQL, the SQL is sent into the event, so we don't have to do anything there as well. But for built-in tests, we have to know what kind of test it is. For example, column cannot be null, stuff like that. We don't get it, so we fetch it from the API first, and then through some config, we can get the SQL back. We run it through our data warehouse. Athena in this case, Athena saves the output to a bucket. The function retrieves that data and then creates the email with the results as an attachment. So the setup of this, once the architecture is in place, which I just show, it's very easy. It can scale to multiple kinds of data quality tests, as I shown before. And also, yeah, once you have everything in place, it takes like 30 seconds to set this all up. So for destination, external webhook. And we also specify email receivers because we want some more flexibility on who we want to send the email to. We don't always want to rely on the owners of the data quality tests. So very quick to set it up. Now, how does it look? Here you have a screenshot of the test case. As you can see, top left, we have the CSV with the data in there. As I mentioned in the beginning as well, we want to be as customizable as possible. We can do this through custom SQL code. To give an example, in this test case, we were sending IDs back to the business user. We went and talked with them, and they said a URL would be way more efficient for them. It would remove one extra step to get to a resolution. So this was done through that. Also, we have a lot of contextual information in there. Think about description of the test case, time of failure, but also the result you see in OpenMetadata itself. For example, you will often see expected 0 rows, but found 20. Something like that is also in the email. And then also some links to create to up the quality of life. Link back to the test in OpenMetadata. If maybe you're a business user, where you want to have a better look at the test, but also links to the query engines. Maybe if you're a bit more analytical, you want to go do some further investigation, that's also possible. And also the SQL code is also added in the email for some more observability. So we discussed this solution with the business owners. As I mentioned earlier, we discussed what kind of data they need to really quickly solve this test. And this also was quite insightful. So then on launch, we saw a big improvement. Errors got resolved. But this is also quite artificial because we told them, hey, we're going to implement this. We're going to do a cleanup. So this was kind of expected that it will all be go green. But then after a few more days, we saw that another error popped up, and it like instantly got fixed. So this was kind of a proof that our solution was working for them. So no issues getting fixed immediately. Also, there was no intervention on our part. We didn't send them any extra information about the test case. They did really resolve it by themselves. Okay. And also, it kind of shows that they took ownership of the data and of the test case. So we were really happy that they fixed it on their own. So to look back, before the data engineers were the middleman, now they are freed up of that, and they can focus more on their core tasks. Also, the owners, they couldn't really react independently, but now they can take up responsibility and agency towards their own data. And also there were multiple steps after an alert. Now this is shortened, and the number of steps for a resolution is also way less than before. Okay, with that, I want to end this initiative. We're also doing some other initiatives with open metadata. For example, increasing test coverage with some reasoning models, but also leveraging GenAI, as a lot of other companies as well, for doing automated pre-analysis of our failed data quality tests, and many, many other initiatives, which we may share in some other spotlight events. With this, I will hand the floor back to you, Nick. Thank you all for listening.
Thanks, David. That was great. It was great to see how you all are, constantly, removing steps and removing those barriers and making it a more efficient process to that resolution. I really appreciate the efforts there, and
Thank you.
seems like it's great results, from it. So thanks a lot, David. Excited to see that, and would be more than happy to have you come back, as you mentioned, as those new initiatives get tackled.